Thank you, Tucker. Thank you for showing that. I'm going to go ahead and share my screen. And please make sure that you can hear
I'm
this.
going to walk through some examples of the seasonality test that Tucker described. These examples are from the paper Identifying Seasonality by Bell, McDonald-Johnson, McElroy, Pang, Monsell, and Chen. I hope that you will see the paper for more details and additional examples beyond what I go through right now. For these examples, the original series, the not seasonally adjusted time series, those are published estimates. The examples I am showing here are monthly single-family building permits time series. These estimates are based on sample data, and they are subject to sampling and non-sampling error. Full information about the data collection and the estimation methods is available at census.gov/construction/BPS. For these examples, we computed model diagnostics, model estimates, test diagnostics, and seasonal adjustment estimates for the purposes of illustration. And those will not exactly match the published seasonally adjusted estimates or diagnostics that might be computed from the published seasonal adjustments, but we did start with the original series that are published. For today's examples, I assume a significance level of 0.05, but users might choose a different level for their purposes. So with that background, let's go ahead and start looking at the example time series. Our first example series is a monthly single-family building permits for the Northeast region of the United States. And let's start with the pre-testing. So I have a spec file opened here, and you can see how I'm going to do a pre-test by fitting the seasonal regressors. So we ran that already, and let's go ahead. Well, before we even look at the test, let's go ahead and look at a graph of the original series. We have some history with the building permit series, so we are pretty sure that they're seasonal, but it's always a good idea to look at the tests. So this is on the log scale. We also can look on the original scale. We are doing a multiplicative adjustment, so it makes sense to look at it on the log scale. I'm using X13 Graph Java to create these graphs today. In addition to this overlay plot, I like to look at the year-over-year plot of the time series. It just shows a really nice representation of the seasonal pattern, if there is such a pattern, and it just gives a very nice overview, an overall idea of what the behavior of the series is. So let's go ahead and look at the test runs that we did. So we ran the seasonal regressors. I will point out that fitting the seasonal regressors, this is not likely to be the model that you would use for the purposes of seasonal adjustment. So this is generally going to be an extra run of your time series so that you can complete these tests. So we're looking at the regression model. They look highly significant, but let's look at the group test statistic. The F statistic here is 77.55, degrees of freedom 11 and 177, and the resulting p-value is 0.00. So we see this as highly significant. Let's move along, and we'll go ahead and run with our chosen model, the model that we would use for seasonal adjustment, and we'll look at more test results. One informal check for seasonality in the original series is looking to see whether the autocorrelation function plot with the appropriate differencing has spikes at seasonal lags. And so we're looking at a monthly time series, so we'll look at lags 12, 24, and 36. So I can pull up that graph for us. We'll look at one seasonal difference and one first difference. And we do see a substantial spike at lag 12. Not so much at lags 24 and 36, but a pretty substantial spike at lag 12. So this is some indication of seasonality right here, although it is not one of the more stringent tests that we recommend. It is a nice check that's available. Another pre-test diagnostic is the spectrum of the original series. You can look at that in the output file. We tend to think of this as the spectrum of the original series, but it's technically the spectrum of the differenced, transformed, prior adjusted series. So this is table B1 from the X13 ARIMA seats run. If you look at it in the output file, it's a text character representation of the spectral plot. The seasonal frequencies are marked with S's. And for visual significance, or VS, we look to see if the peak is at least 6 stars tall. A star is just the measure of an asterisk. It's the measure of one of these text characters. So we look to see that these peaks are 6 stars tall or more. And so we can see at frequencies 1 over 12, 2 over 12, 4 over 12, and 5 over 12, they are definitely large. At 3 over 12, it's a little bit iffy whether it meets the height criterion. We also can look at a spectral graph, a high resolution spectral graph from X13 Graph Java. One nice thing about these high resolution graphs is that if the peak is visually significant, there's an S label right in the graph. And you'll see here for frequency 3 over 12, there is no S label, so this did not meet the criteria for visual significance. One other nice aspect of the high resolution graphs is this indicator bar on the side. The top of the indicator bar is the median level of all our measured frequencies. And one criterion for visual significance is that the peak is above this median level. So 3 over 12 does meet that. The other part of this indicator bar is the height. This height is that 6 stars necessary for VS, for visual significance. We can see that at 3 over 12, it's not quite this tall. So that's why it was not flagged as significant or visually significant. So all the checks, the graphs, the pre-tests that we've done, they all indicate evidence of seasonality. So we can feel confident in seasonally adjusting this time series, although once we seasonally adjust it, we will want to check quality diagnostics before we publish it. So now that we know that we want to seasonally adjust the series, let's go ahead and look at the post-test diagnostics, the test for residual seasonality. For this run, we happen to use an X11 method of seasonal adjustment for the series, but the post-test diagnostics are the same whether you're using the X11 method or the SEATS method of seasonal adjustment. So we'll go back to the output file, and one of the diagnostics that we want to look at for the post-testing is Maraball's QS statistics. For post-test purposes, we recommend testing over a shortened span, a subspan, at the end of the time series. And so this is the table for the QS statistic. It's available for the full series, but for post-testing, we want to look at the subspan. So I'm pulling up the second table. And we'll want to look at the seasonally adjusted series and the irregular, and both of these are also available for the extreme value adjustment of those components. These are all either 1 or very close to 1. So that means that we failed to reject the null hypothesis that there was no seasonality, no residual seasonality. So seeing these results where we do not reject the null hypothesis, this is a good result for our seasonal adjustment. We just talked about the spectral diagnostic as a pre-test diagnostic, but it also is a post-test diagnostic. So we're going to look at that as well. So we've already run our seasonal adjustment. And this is the spectrum of the transformed differenced seasonally adjusted series. And we also can look at the spectrum of the irregular component. For both of these, there appears to be a bit of a peak at frequency 2/12. We note right away that there is no S label, so we know that these are not visually significant. In fact, if we look at the indicator bar here on the right, for the seasonally adjusted series, this small peak at frequency 2/12, it's not even above that median level of our measured frequencies. For the spectrum of the modified irregular, it does appear to be above that median, but it's not tall enough to be considered visually significant. So summarizing for the Northeast, the QS statistics and the spectral diagnostics, they provide no evidence of residual seasonality at our established significance levels. So if this adjustment meets other quality measures that we rely on, this is an adequate adjustment. Let's move on to our next time series example, and that's the U.S. total single family. The U.S. total single family, it's the sum of the four regions, the Northeast, the Midwest, the South, and the West. Our interest in the Midwest, our interest in the U.S. total is in the indirect or the composite seasonal adjustment that we've done. When we run a composite adjustment, we're also running a direct adjustment at the same time. So my point here in looking at this example is that we want to ensure that we're looking at the indirect diagnostics for the U.S., not the diagnostics for the direct adjustment of the U.S. So we'll first look at Maraval's QS statistic. Again, it's provided for us for the full series, but for post-test purposes, we prefer to look at the shortened subspan of the time series. And we want to make sure that we're looking at the correct tables. So we're looking for the tables that say that they are for the indirect adjustment. And we see that for the indirect seasonally adjusted series and for the indirect seasonally adjusted series adjusted for extreme values, the p-values are both showing as 1. So again, we fail to reject the null hypothesis. So this is again a good result for our seasonal adjustment. We can look at the spectral plot as well. And again, when we go to graph the spectral plot, we don't want to grab the plot of the seasonally adjusted series for the US. We want to plot the indirect seasonally adjusted series. And so that's what this is here. And we find no peaks at the seasonal frequencies. So not even small peaks at our seasonal frequencies. There is, however, a T label over this trading day frequency. It appears that there might be possibly residual trading day effects. And so we would need to review this. But that is a topic for another day. In summary, the QS statistics and the spectral diagnostics provide no evidence of residual seasonality in the composite seasonally adjusted time series at our established significance levels. But the spectral diagnostic indicates the possibility of residual trading day effects. So this adjustment warrants further review, but the indirect adjustment does appear to have removed the seasonal effects. So with that result, I will end here, and I thank you for your time and your kind attention.
Okay.
Thank you. All right, we have 4 minutes for questions. If you have a question, oh, Wendy, do you have your hand up? No, sorry. If you have a question, you could type it in the chat, or if you want to ask it out loud, just put your name in the chat. Or maybe we don't have any questions because everything was so clear. All right. So a question, are the QS statistics available in X13 ARIMA seats? And I could answer that, but I feel like I shouldn't.
You can answer it. Yes, they're in the X13 ARIMA seat software.
They are. They are in the output from X13 ARIMA seats. And by default, you'll see both the full series and the shortened series. Oh, you're welcome.
Since we do have an extra minute and the questions aren't flowing in, I left it out of the the example just because it would take a little bit of time to explain. But there's even another QS diagnostic. If you have a monthly time series, you can ask for the QS statistics for the quarterly version of that monthly time series. And that's helpful if your monthly series get transformed into quarterly for some reason, like, for, GDP or for other purposes. So there's even more to the QS than what you've seen so far today. There is so much more information in the paper as well. So I do hope people will look at that.
All right. Kathy and Tucker, can you see this question? What role should economic theory play in analysis?
Mm-hmm. So the approach that we use in the software is statistical. And a knowledge of the time series and economic knowledge, like where it's, what it's measuring, how it's been collected and so forth, may lead to certain expectations. Programmers, program analysts may know something about construction starts or retail sales. That's economic knowledge that may influence what they expect to see in terms of seasonal patterns, holiday patterns, outliers, and so forth. So that's sort of a metadata or paradata that may inform an analysis. But it doesn't enter directly into any of the statistics. It just may influence which statistics, what span somebody uses, or what kinds of regressors they may insert. I guess there's a second part of the question. Seasonality in one direction, test show in the other direction. I'm not sure what's meant by direction of seasonality. like, I guess we have high December values, or we expect to see that, and instead they dip and go in the opposite direction. Maybe that's what's meant. Well, if our economic intuition differs with our statistical results, then we will go back and double check our results. But if everything's correct, then we may have to amend our economic intuition.
Thank you, Tucker. Thank you for the questions also.